These are the frequently asked questions for the pre-calculus review of Chapter 7. Starting with number 48 here, it says we have an inventory. A company sells 4 models of one name brand all-in-one fax, printer, copier, and scanner machine at 3 retail stores. The inventory at store I, so everything in the rows is store I, and up above here, model J, because it's always rows by columns when we look at the labels for matrices. That's represented by S sub I sub J in this matrix below. And then the wholesale and retail prices of those model I's are represented by the prices that we see in this matrix. So it says determine the product SP. Well, we're going to need to take this 3 by 4 times this 4 by 2 matrix. And we should get a 3 by 2 when we are done. So this is the 180, 275, oh, and I wrote way too big for that, 355, and 590, 269.99, 399.99, $499.99, and $799.99. All right, and I will pause and get that into the graphing calculator. The 2 matrices in here, let me pull those up so that you can see them. And we'll go into edit so you can see all the numbers that are in there. So matrix A, there is our 3 by 4, and I've got this thing opened up a little bit bigger so we can see everything this time. And we see the 16, 10, 8, 12, 12, 0, 10, 4, 4, 12, 0, 8. And then second matrix. And this time matrix B. And again, you can see that the prices are located in that matrix. So we have to go back to the main screen whenever we want calculations. We'll recall the names of the matrices. So second matrix number 1 times second matrix number 2. And we get this nice little matrix that you see here. So that's the matrix that we put down as our answer for the product of S&P. $15,550, $21,919, $54, $8,070, $11,439.74, $8,740, and $12,279.76. Now, the second part of this problem asks us to figure out what on earth we just found. Well, we just took their inventory of these models times these prices. And then we took the inventory times these prices. And the first row was the wholesale price, and the second row was the retail price. So what we just found for part B was, we can just put, it represents the wholesale and retail values oh goodness, that doesn't look like retail at all. At each store. And I might just mention that would be store I that they had talked about there. So it represents the wholesale and retail values. Oh, well, yeah, we might as well clean it up a little bit. It represents the wholesale and retail values of inventory at each store. And that's a really accurate explanation of what we have there. Wholesale and retail values of the inventory at each store. And that's something that has to be done at the end of a year for any small business owner. You know, you have to say, what do I have sitting in inventory? All right, number 10 says, use the reduced row echelon form of the augmented matrix to find the partial fraction decomposition. And the good thing about number 10 is they've practically handed us how we have to set that up. I mean, that's saying, hey, this is what you do. Now, we would have found that out anyway ourselves because we see here are our denominators, and neither one of those is reducible. Those are irreducible quadratics. They need linear numerators. So ax plus b over x squared plus 4 plus cx plus d over x squared plus 9. Well, let's figure out what this is going to be. I mean, pretty obviously the LCD is both of them. So what we would need to do is multiply ax plus b times x squared plus 9, because if we were trying to get a common denominator, that's exactly what we would do. And we're going to add cx plus d times, we need the other one, which would be x squared plus 4. So again, the reason that we just drop the denominators at this point is because we don't need them. The denominators are already the same. We're interested in getting the numerators to be correct. So we'd use some FOIL, and it's not beautiful FOIL because these are nasty, but ax cubed plus 9ax plus bx squared plus 9b plus cx cubed plus 4cx plus dx squared plus 4d. And I was writing too big. I almost used up all my space here. And then, looking back at the problem, we find out what our x to the thirds that we have here need to equal. Well, they have to equal 5. Our x squareds have to come out to a negative 10. Our x's have to come out to a 5. And our constants to negative 5. So let's go set this up. Ax cubed plus cx cubed has to come out to be 5x cubed. Go after the squareds. Bx squared plus dx squared, our x squareds have to come out to be a negative 10x squared. 9ax plus 4cx has to equal 5x. And finally, our constants. 9b plus 4d needs to equal negative 5. So now what we can do is we can go ahead and drop the x's. We don't need the variable. So a plus c equals 5. b plus d has to equal negative 10. 9a plus 4c has to equal 5. And 9b plus 4d has to equal negative 5. And the instructions here, I believe they said we're supposed to use the RREF. Let's take a peek and see. And they did. Use the reduced row echelon form for the augmented matrix to find the partial fraction decomposition. So RREF is what we're going to do, but we need them in the right spots. So let's get this matrix put together. And you need to remember we had A, B, C, and D, and then we're going to have our constants over on the other side. So 1A, 0 B's, 1C, 0 D, and a 5. 0A, 1B, 0C, 1D, negative 10. 9A, 0B, 4C, 0D, and a 5. 0A, 9B's, 0C, 4D's, negative 5. And I will pause this and get that into the calculator. I went ahead and put the matrix in as matrix D. Now from the main screen, clear everything off of this. And we need math. And then you can either hit alpha B or scroll all the way down to RREF, second matrix, and I have that, like I said, in D. There are the solutions. Remember that what we were looking for here was A, B, C, and D. And these are what they are, depending on where the 1 is located. So if the 1 is under A is a -3. If the 1 is under B, it's 7. If it's under C, that's 8. And D, -17. So we'll go ahead and put this all together with what we know we're supposed to be doing. So A was -3, B was 7, C was 8, and D is -17. And we had AX plus B over x squared plus 4 plus CX plus D over x squared plus 9. So let's put those A, B, C's, and D's in the right spots. -3x plus 7 over x squared plus 4 plus 8x minus 17 over x squared plus 9. There is our partial fraction decomposition this was from section 7.4, number 10.